This lesson is called Trigonometric Ratios. It begins our study of trigonometry, and it's going to be a brief study in geometry, and you will do a lot more with it in pre-cal. So we're going to look at the basics here, and for short, we are going to call these trig ratios. Okay? It says I want to be able to represent each of the trigonometric ratios as a comparison of the sides and hypotenuse of a right triangle and apply them to find missing lengths. Okay, so we're still talking about right triangles. So we're just extending our study of the relationship between the lengths of sides and right triangles, which starts with Pythagorean theorem. A squared plus b squared is equal to c squared. Okay, that's Pythagorean theorem, and that explains the relationship between the lengths of the sides in that triangle. And that's great. We use it a lot. However, we have three variables, so in order to find one side, you need the other two. So there are some limitations. And so the next thing we learn is we talk about special right triangles. We have a 45, 45, 90. Okay? And we can describe the relationship between the length of the sides as x, and x to the square root of 2. And then we had a 30, 60, 90. And we could describe it as x, 2x, and x to the square root of 3. So this was a lot better than Pythagorean theorem because we only need one side to find the other two because we're using one variable to describe the relationship between all the sides. However, there are a lot more right triangles than just those two. I mean, there's an infinite number of right triangles. And so those two are very helpful because they happen a lot, but there's a lot of limitations here as well. So from here we'll go to trig ratios, which is again just explaining the relationship between the lengths of the sides and a right triangle. Okay? And now here if we read this, it says ratios of the lengths of the sides of a right triangle related to the acute angles. So what that means is that these ratios do not apply to the right angle. And we'll see that in our examples, but the acute angles are the two angles that are not the right angles. If we have one right angle, the other two both have to be less than 90. The other two together have to add up to 90. So by definition, they're less than 90 degrees. Okay, so the three most common ratios, let's pronounce these, are sine, cosine, and tangent. We abbreviate these as sine is sin, cosine is cos, and tangent is tan. Okay, now again we're talking about an angle. So we have a right triangle, and it could refer to either of the other two angles. And so the abbreviation that we'll use when we're talking about just a generic triangle is we say the sine of some angle, and we use this Greek letter called theta, spelled theta. So this would say the sine of theta, the cosine of theta, or the tangent of theta. That is just saying the sine of some angle, the cosine of some angle, and the tangent of some angle. Now, if these angles were labeled like A, B, and C, then you could say the sine of angle A or the sine of angle C. Again, you can't say the sine of angle B because that is the right angle and we can't use that one. So the definition, what are the definitions? Well, the sine is defined as the length of the opposite side divided by the length of the hypotenuse. And we'll explain opposite here in a minute. The cosine is the length of the adjacent side divided by the length of the hypotenuse. And the tangent is the length of the opposite side divided by the length of the adjacent side. And usually you'll see these abbreviated like this: opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So pause the video for a moment and make sure that you have all of this written down. Okay, so now I'm going to scroll down. let me stop here. This is a common device for memorizing these ratios. You may see this again. However, some students find it more helpful than others, but Soka-toa, Soka-toa. Some teachers will have you chant it like an Indian chant, Soka-toa. But this stands for S is sine, opposite over hypotenuse. C is cosine, adjacent over hypotenuse. T is tangent, opposite over adjacent. So if that helps you to memorize it, you can write that down, Soka-toa. Okay, now let's go to our first example. All right, this first example, they ask us to find the sine, cosine, tangent of A and sine, cosine, and tangent of B and express each ratio as a fraction. Okay, when we're looking at this triangle here, we have lengths of sides, and we have, again, A, B, and C. So one thing I would ask you to do is when you have one of these, mark your hypotenuse. Okay, 13 is the hypotenuse in that triangle. The reason I say mark that is because the hypotenuse never changes. It doesn't matter how we're looking at the triangle. The hypotenuse is always the side across from 90, and it does not change. However, opposite and adjacent change depending on which angle you're looking at. So when they ask for the sine of A, and the sine is opposite over hypotenuse. Okay, the sine of theta is opposite over hypotenuse. So from A, the opposite side is always the side that does not touch the angle. It's across from the angle. Okay, if you look, this side here that has the length of 12 touches A. The hypotenuse also touches A. The opposite is across from it. So opposite is 5, and again, the hypotenuse never changes. That's 13. But when we ask for the cosine of A, the adjacent side is the one that touches it. Well, this side here, 12 touches it. Well, so does 13. But it's the side that's not the hypotenuse. This is 12 over 13. And then the tangent of A is opposite over adjacent. So 5 over 12. So that is the sine of A, the cosine of A, and the tangent of A. Now, if we want to go to the sine of B, now we're looking at this angle. So the hypotenuse is still 13, but the side opposite B is 12. So this is 12 over 13. Looking at B, the adjacent side is right here, 5 over 13. And from B, opposite over adjacent is 12 over 5. So you have to be careful and make sure that you're looking at the right angle and just apply the definitions. Now, mark your hypotenuse will help. Please pause the video and do the quick check yourself. The first thing you should do is mark your hypotenuse. Okay, hope you paused it and did this. So if you're looking at the sine of S, here is S. Opposite is 3. Hypotenuse is 5. From S, the cosine, adjacent is 4. Hypotenuse is still 5. From S, opposite over adjacent, 3 over 4. Okay, now we switch and look at E. So when we're looking at E, the opposite side is 4. The hypotenuse hasn't changed, it's still 5. From E, the adjacent is 3 over 5, and from E, opposite over adjacent is 4 over 3. So those are the ratios. Okay? So now, it says, use the trigonometric tables to evaluate expressions involving trig ratios. Find each value using the trig table attached. Okay, I'm going to try and flip back and forth and show you this here. However, today we usually just use calculators for this. At the middle school, I'm not exactly sure which calculators you are using. And so maybe you have someone there that can show you how to use it, or please tell me which calculator you have. And if y'all have the Inspires, I can explain that, or tell me which one, and I could probably explain you, make a video even of how to use it, but I just need to make sure which ones. If you can Skype, we're going to be using the Inspires. Okay, cosine of 41. The tables are easy to use. We just have to go back them. So if you're looking for the cosine of 41, you have the table at the end of at this lesson, and I put a separate one that you can print out as well. So the cosine of 41, so let me just scroll. Okay, so you see that we have sine, cosine, and tangent, and we're looking for the sine of 41, so we're looking in this first column. Okay, so let's see. We are just going to scroll down here, and here's 41, so 0.6561 is the sine of 41, 0.6561. Oh, sorry, cosine of 41. Let me go back. Not sine. Cosine is the middle one. So the cosine of 41 is 0.7547. .7547. Okay, so again, we're just going to have to be scrolling back and forth. So now let's look at the sine of 78. So again, sine was that first column. And let's see. Here we go. 77, was it? 0.9744. Okay, sine of 78. I have a hard time scrolling back and forth. 0.9781. Okay, so .9781. And then we want the tangent of 23. So scroll back down. Tangent is the last column. 23 degrees is right here. So 0.4245. And then the last one is the sine of 53. So again, the first column again, sine of 53. Let's see, right here, 0.7986. Okay, so you just have to go back and forth, and you're just looking for the values from the table itself. Now, if you're a little confused, because before we had, remember, like say we had a triangle that had the 3, 4, 5. Let's just say that was it, and this is A, B, C. And so we said that the sine of A, opposite over hypotenuse, so the sine of A here would be 4 over 5, right? So that is a ratio, and that's just a ratio expressed as a fraction. But if you put that in your calculator, you're going to get a decimal answer. And so this here, decimal answer, refers to just the length of the side written as a fraction put into your calculator, expressed as a decimal. And I'm going to end this video, and we'll put on part 2 and explain how to use these.